Okay, these are the notes for solving differential equations. I recorded them all during class, and then I went back to do something on the camera, and I hit delete accidentally. And so it is just me in the room by myself, so you won't get any questions. Sorry, but at least you'll get an idea what we're doing. Okay, so given below are differential equations. That just means an equation that is set up with a derivative. So if you look at the first of this, I've got dy over dx, which is what makes this a differential equation. It also has a given initial conditional value. So right here, in this case, this derivative has a function that has an ordered pair -1 and 2. So this is a derivative. This value actually goes with the function, which means, of course, we're going to have to take the antiderivative in order for that to be a useful value to us. So, we had just talked a moment about what we need to review, and one of the things that we talked about needing to review is implicit differentiation, which is when you have y's and x's in the same function. I do not have y's and x's in this same one, but in this same derivative, but I will in just a minute. So, but I do have dy dx. Now, if you'll remember, when we take an antiderivative, it always has the integrand and then some function right here, and then the letters dx. So, if I'm going to take the antiderivative of this function, it needs a dx on the end, and I don't have one. But there is a dx on the other side. So if I were to multiply this side to clear the dx, I would also have to multiply this side by the dx, which means I now have dy equals 6x squared plus 6x plus 2 dx. So now I'm ready to take the antiderivative. Now, in order to save space, I'm just going to go ahead and sneak in my integrand. And now I will actually take the derivative. When you take the derivative of dy, I'm sorry, I'm going to take the antiderivative. When you take the antiderivative of dy, you're back to y. I'm going to take the antiderivative of all this. I am going to write this step out, so that would be 6x cubed over 3 plus 6x squared over 2 plus 2x, and don't forget plus c, because at this point these are indefinite integrals. Now we'll work on the fact that we actually have an f value up here in just a minute. Let me simplify that. That'll be y equals 2x cubed plus 3x squared plus 2x plus c. And now the fact that I know this initial condition, I will plug it in. So I get 2 equals 2 times -1 cubed plus 3 times -1 squared plus 2 times -1. And that's going to equal c, or that's going to plus c. So I'm going to do this to figure out what c equals. So let me simplify that. So I get c equals 3. That means I can go back and plug this into this. Y equals 2x cubed plus 3x squared plus 2x plus 3. That's my original function, so I am going to write it in f of x notation. Alright, not bad, right? Pretty easy. Okay, so the same thing over here on number 2. Before I can take the antiderivative, I need a dx over there with that function. But it's good because I have one on the left-hand side. So I'm going to multiply both sides by dx. On the left it cancels, and on the right it'll place it at the end. So I have dy. Now at the same time that I do this, I am also going to change this to x to the 1/2 power. So everybody's okay. I don't want to lose anybody here. So I got 2x to the 1/2, and now there's a dx at the end because I'm multiplying both sides. Now I'm still not going to take the antiderivative yet, because I need to simplify this. Remember, we really want to put these in polynomial form if we can, before we take an antiderivative. And right now it's in rational form because it has an x in the denominator. But I can move that x up if I make that exponent negative. So I'm going to do that. This stuff is already upstairs. I am now moving the x to the -1/2 up from downstairs. downstairs. Okay, and one more thing I'm going to do is I'm going to split that 2 belongs to all the pieces here. I'm going to distribute as well as fix the 2 before I take the antiderivative. So now I have 1/2 x to the negative 1/2. I'm distributing this x to this. Remember, you add exponents. So that's going to make this 2 divided by 12 is 6. X to the 3/2 plus negative half is just 2 over 2, so that's 1. So I'm going to write it just like that. Dx. Now let's go ahead again, in the interest of saving space, because they give us these tiny boxes, I'm going to take the integrand, stick it in there. That's going to give me y equals, again I'm going to write this step out, 1/2 x to the, now remember you're adding 1 to this, it's going to be the positive 1/2. It'd be divided by 1/2, but if we keep switch flip, that's multiplied by 2. That's all this piece, plus 6x squared divided by 2 plus c. All right, can simplify one more thing. Those 2's cancel, and that's a 3. So my function is now, I could write it as x to the 1/2 or square root of x. I'm going to go ahead and write it as square root of x plus 3x squared plus c. Now we can plug in our values. I'm going to save space. I'm going to do it right over here. So I get 2 equals square root of 0 plus c. So it looks like c equals 2. Plug that back into the function that we found, which is this function. So f of x is the square root of x plus 3x squared plus 2. And that's it. Alright, so the next one is a little bit different because in this case, if you look at the function that I have on the right-hand side, it does in fact have a y in it. So that does take us to implicit differentiation, remember when we have both x's and y's, and we'll do a review of that in a couple of days. But in this case, if you'll just remember all my y's need to be with my dy, and all my x's need to be with my dx, in this case, I could just cross multiply, and that would happen. So 2y times dy is 2y dy. Dx times all of this is going to be x squared plus 2x dx. Now, because we're already in polynomial form here, I am ready to take the antiderivative, so I'm going to sneak that integrand in there. Now, because we are finding these as functions where they are y equals, we don't need a constant with our y, so we're just going to take the derivative of this side. So the derivative of 2y would be 2y squared divided by 2. I'll simplify that in a minute. The derivative on the right side is x cubed over 3 plus 2x squared over 2 plus c. This side has to have a c because we don't know what's happening on the x side. We know that our function is just y equals. Alright, so now let me simplify this. So I have y squared equals x cubed over 3 plus x squared plus c, which, by the way, let me write it the other way, or it could be written as y squared equals 1/3 x cubed plus x squared plus c. You might see it either way, so just want to make sure you're aware they're the same. Now let's plug in the values they gave us. They gave us f of 0 equals 2. So that's going to be 2 squared equals 0 plus 0 plus c. So c equals 4. Alright, so let's plug it back into the function that we got, which is this one or this one, no matter which one you're plugging into. So I have y squared equals 1/3 x cubed plus x squared plus 4. Now here's the only problem. When we're finding these as functions, we need them as just y equals. Easy fix. Take the square root of both sides. I get y equals the square root of 1/3 x cubed plus x squared plus 4. Now, that's it with one little caveat. Remember, when you take a square root, there's actually 2 answers always. So in this case, my y value is supposed to come out positive. So this is the positive square root answer. Now, because it's the positive one, you don't have to put that in front. But in a minute, we'll do one where you do actually have to make indication of which one it's supposed to be. All right, so if I review at this point, I would pause the video and see if you can do 4 on your own, and then restart it. But I'm just going to keep going. All right, we're going to do the same thing here. We're going to cross multiply. I get y dy equals x plus 2 dx. Sneak that integrand in there. Take the antiderivative of both sides, so I got x squared divided by 2 equals y squared divided by 2 equals x squared divided by 2 plus 2x plus c. So now I'm going to plug in, actually, before I do that, let's solve for y. Now let's plug in and then we'll solve for y in a minute. You can solve for y here or you can solve for y in a minute, but let's go ahead and plug in what we have. So I got negative 3 squared divided by 2 equals 1 squared over 2 plus 2 times 1 plus c. I'm going to go over here to save room. That's 9 halves equals 2 1/2, which is 5 halves, plus c. Subtract 5 halves from both sides. That gives me c is 4 halves, so c equals 2. Hope you followed all that. Sorry about that. Okay, now that I know what c is, I'm going to go back to here, and then I'm going to have to solve for y. All right, now to solve for y, I'm going to multiply both sides by 2 to clear that 2. That cancels that. You get y squared equals, that'll cancel, plus 4x plus 4. Now we're still solving for y. Take the square root of both sides, and you get y equals the square root of x squared plus 4x plus 4. Now, here's where it does matter. Go back and look at that. It's a negative 3, so my y values have to come out negative. So I am going to put a negative in front, knowing that I'm not just taking the principal root, which is a positive root, but I'm going to take the negative one. All right, now this is the last one we did today. So process is almost the same, but if you'll look, I have a y, and I need to get it over here, but it is up on top. But that's okay, we'll do it just like we've done the others. I need a dx over here, so let's multiply by dx to cancel. So now I have dy equals x to the 4th, y minus 2 dx. I'm going to divide by y minus 2. That would give me, now I'm going to write this as 1 over y minus 2 dy, so that the dy is next to it, so I can put the integrand in front. Equals x to the 4th dx. Now, I could go in and write this in polynomial form by grouping this all in parentheses, moving it upstairs and putting it to the negative 1. When you do that, if I'm taking the antiderivative, negative 1 plus 1 is 0, and you would have to divide by 0, which is undefined. If you remember what we did when that happened before, when we had 1 over x, that's because the derivative of 1 over x is natural log of x. So that's going to be the derivative on this side as well. The antiderivative. So I'm going to take the antiderivative, and I'm going to write this, take the antiderivative of this side, and you get natural log of y minus 2. Now, I'm putting that in absolute value because if you remember, you cannot take a negative logarithm. So my argument cannot be negative, and because there's subtraction inside of here, that could potentially happen. So that's why I've put those absolute value signs, because this is still going to work if we put the absolute value signs and make sure we keep it positive. Taking the derivative over here, I get x to the 5th divided by 5 plus c. Now let's plug in what we know. So natural log of 0 minus 2 equals 0 over 5 plus c. So it did in fact happen, but we're taking the absolute value, so it's just going to be natural log of 2. This is a non-calculator question, So I'm not actually going to find that. It'd be a nasty decimal. So I'm not going to find that. I'm just going to leave it as natural log of 2. That is my constant. It's a nasty decimal constant, but it is 1. So now I can plug that back into this function. Natural log of y minus 2 equals x to the 5th over 5 plus natural log of 2. Now I actually think that this is where we stopped. Yeah. So I'm going to stop right here for today because I'm going to finish this on another video tomorrow. So that's all you need to know for today.